So we are talking about induction generators or sorry, asynchronous generators, and asynchronous generators are induction generators. So let's just do a bit of a review of induction generators. So those are ones that produce electrical power when the rotor is turned faster than synchronous speed. They're often used in wind turbines because in this case, speed is always a variable factor. So these are simpler systems because they have a lot less parts, no brushes, no commutators, and perfectly suited to the variable speed of the wind, which can be um, captured, studied, and converted into a signal where you can provide feedback to uh, change the synchronous speed. So let's just do a little bit of a review of what slip is. So the rotational speed of a motor, we're going to call omega 1. When that is the same as the speed of the rotating magnetic field, which is a synchronous speed, then the relative speed would be 0. That would mean no EMF would be induced in the rotor. There's no change in the magnetic field, no current in the rotor, no force, no torque, no power. However, when a wind turbine is delivering power to the generator, mechanical torque is delivered to the rotor, and the torque is related by this equation. So the torque is going to cause the rotor to accelerate in an angular motion. As the speed of the rotor becomes greater than the synchronous speed, then it has a relative velocity of the speed of the rotor, omega 1, minus the relative speed with respect to the magnetic field in the stator, will cause an EMF to be induced and current will start to flow. The frequency of the current would then be defined as the difference between that synchronous speed and the rotor speed, divided by the synchronous speed multiplied by the grid frequency. Since the current is now flowing, this is directly related to the slip, and the slip is just a ratio between that rotor speed and the synchronous speed. And as slip increases with increased load, the slip increases with the increased load. Therefore, there's going to be more torque. So there's an opportunity in an induction generator to control the amount of torque, therefore power, since power is directly related to the torque, by changing the relationship between the rotor speed and the synchronous speed. So what the asynchronous the asynchronous generator is going to look for is it's going to look for what is that wind speed coming in. Then it can vary the synchronous speed to optimize slip in order to increase that torque, therefore increase that power.